We come across instances where two pumps are operating together all the time. Can you clarify as to which system curve we need to consider?
Sure. Well, this is a variation in the classic parallel operation, because in the classic parallel operation, you have one pump operating into the system, and then the second pump is switched into the system to increase the flow. That's not the situation we're looking at here. We're looking at two pumps giving you the main duty. And if you want to reduce the flow, you're going to reduce the speed of both pumps to give you that lower flow. That lower flow will produce a lower head in the system, so you need to see where the operating points are for each pump to determine their efficiency and power draw. You may need to get information from your client about the specific requirements of system resistance. So it means drawing a new system resistance curve. It's not likely that you can generate that on a single pump curve to get an operating point for that pump. You have to determine the operating point for the pump using the two pump system curve.
What happens if the customer decides they want to run one pump only and not two pumps?
Well, if they do that, they've got to see how that individual pump runs in the two pump system curve. And that means that they have to look at the intersection point of this single pump curve with the system resistance curve for two pumps operating in parallel. And if you look at that, you can see there is no intersection point. In that situation, what we'll do, the single pump will do is the flow will collapse at this point, and it will just drop down to an unknown, unstable position, and you'll get vibration, you'll get noise, you'll get all sorts of unpleasant phenomena.
In order to bring the system curve back onto pump one, what we see is they manipulate the valves in the system.
Yeah, and that's understandable. If that you throttle the valve in the two pump system, what you will do effectively is to bring this curve up to a situation where the pump curve does intersect that manipulated system curve. And then you will get an operating point where it could be satisfactory. But you cannot get it with a fully open valve with this system resistance curve. Just not possible.